Hi guys, these two problems are intended to help with number 8 and number 10 on Achieve in section 3.8. They're both really good problems. The first one here has us looking at something like, and remember yours will be slightly different because it regenerates for each user, but probably the only thing different is the numbers in the problem. But number 8 is going to look something like 5y over x plus x over y is equal to 5y. So this whole section is about implicit differentiation, so we need to take the derivative implicitly, meaning every time you take the derivative of x, it's the same thing as it's always been because dx is 1, but whenever you take the derivative of any term with a y, you have to put a dy dx there. So now, I'll look at the first one and say, well, it's a quotient. I use the quotient rule. I squared the denominator, x squared. Then I bring that denominator to the numerator times the derivative of the numerator. And please be very careful there. The derivative of 5y is 5 times, well, the derivative of y with respect to x. That's the dy dx there, the derivative of y. And then minus the numerator, 5y, times the derivative of the denominator. And remember, the reason there's just a 1 there is because the derivative of the denominator would be dx dx. Well, dx over dx is 1, unlike the dy over dx. Now, I'm done with the first fraction. I go to the second one. I square the denominator in the second fraction, so I can say, okay, I know that that's going to give me the y squared. I bring that denominator up to the numerator, y, times the derivative of the numerator, which is just 1, minus the numerator times the derivative of the denominator, which is going to be our dy dx. Now, all of this is equal to the derivative of the other side. Well, the derivative of y, as we've been saying, is dy dx. So the derivative of the right-hand side, 5 dy dx. Now, the only thing I've done from this step to the next is I've split apart each of my quotients. What I need you to remember is just like you would distribute when you multiply, you distribute when you divide. So this first expression comes from this fraction. If I say, well, I can divide x squared into the first term in the numerator, when I do that, please notice x in the numerator cancels with x squared in the denominator, leaving me an x in the denominator, and I would have a 5 left in the numerator, multiplying that dy dx. All of this comes from the first term over x squared. Then I would have minus 5y over x squared. That's right here. Now, in the second one, when I distribute the y squared into each term in this numerator, y divided by y squared reduces down to plus 1 over y. Then I bring down my minus sign. I have x dy dx over y squared. I would rather write that as x over y squared all times dy dx. Now, I didn't change anything on my right-hand side. This has enabled me to get all of my dy dx terms out by themselves. So I say, now I'm going to gather every dy dx term on the same side. So I say, let's bring dy dx over here. When I factor it out of this term, I'm going to have 5 over x. Factor it out of the second term here, you have your minus x over y squared. And please notice, I brought the 5 over, it becomes a minus 5, and again, the dy dx is factored out. Now, on the other side of the equal sign, I put any term that did not have a factor of dy dx. So you'll see the negative 5y over x squared becomes a positive 5y over x squared on the right. The plus 1 over y becomes a minus 1 over y when I move it to the right-hand side. So now at that point, I come down and I say, okay, then dy dx is equal to everything I had on the right-hand side divided by what was previously multiplying dy dx. Now, I'm not 100% sure. Achieve may accept this answer right here in this format. I'm thinking that they won't want fractions inside the fractions, though. So while you might try this, this is a correct answer. I wanted to go ahead and be sure that I work it out as the way I know Achieve will accept the answer. So let's get rid of any fractions inside the fraction. I'll look for the least common denominator of all denominators in there. I know if I multiply by x squared and by y squared, every single denominator would cancel. So I multiply by x squared y squared in both the numerator and the denominator. And now when I multiply by x squared y squared in that numerator, the x squared is going to cancel out with the term in the first one, and I would be left with 5y times y squared is 5y cubed. When I distribute it into the second one here, this y cancels with the y squared and leaves me minus x to the second y to the first for the second term in the numerator. I also distribute that x squared y squared to every term in the denominator. In the first term, it's going to reduce the power on this x by 1 and give me 5x to the first y squared. It's going to cancel the y squared out in the second term, and I would have minus x times x cubed, so minus x times x squared is x cubed. And then the last term, you just have minus 5 times both x squared and y squared. At this point, the only thing I've done is I've factored the numerator and denominator. You could factor out a common factor of y in the numerator, and I factored out a common factor of x in the denominator, and that was my fully factored final fantastic form of that answer. That's a good problem. I love it. I'm just glad someone asked me that question. Now number 10, it's not quite as bad, but again, I think that we might need to simplify in order to get achieved to accept to our answer. I'll talk about that in a moment. The first step's not bad at all. It's wanting us to look at an expression similar to this and take the derivative. So we take the derivative implicitly. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. And then I can say, well, the derivative of y to the 7/8. I bring the 7 over 8 down in front times y to the negative 1/8. Keep in mind that come from 7 over 8 minus 1 to get to the negative 1 over 8 power. Times the derivative of the inside. Well, it's the derivative of y, so I have to put a dy dx there after that one. Same thing on the other side. The derivative of y is dy dx. I keep that with the coefficient of negative 7. At this step, I go ahead and I just gather any dy dx terms on the left. That gives me 7 over 8 y to the negative 1/8 plus 7 when I move that term to the left-hand side. I had to move my x to the right. So that became a positive, the positive became a negative when I moved it to the right, and I have a negative 1/2 x to the negative 1/2 power. Now we can say, so dy dx, it's equal to what I had on the right divided by what was previously multiplying dy dx. That's your 7 over 8 y to the negative 1/8 plus 7. Now, this answer right here may be perfectly fine for full credit. I'm not sure though. So the answer that I know that they would like is if you get rid of any negative fractional exponents and any fractions in your problem. So that's what I'm trying to do here. The first step, I was trying to get rid of the fraction 7 over 8 and the negative 1/2. I can do that by multiplying the numerator and denominator by 8. I can get rid of the negative exponent of x to the negative 1/2 by multiplying by x to the positive 1/2 in the numerator and denominator. And I can get rid of the y to the negative 1/8 by multiplying by y to the positive 1/8 in the numerator and denominator. Now, when I simplify this, I'll get negative 1/2 times 8 is my negative 4. Notice your x's cancel and you'll have y to the 1/8 in the numerator. Your denominator, 7 over 8 times 8 is where the 7 comes from there. We knew that the y to the 1 over 8s would cancel because of the opposite signs, but you are going to have the x to the 1/2 term with that first one. And then the second term, you'll have 7 times 8 is 56, and then you'll have both the x to the 1/2 and the y to the 1/8 for that term. Then the only thing I've done from this to this is I noticed the denominator, once you multiplied by the terms to simplify out the expression, we had a common factor of 7 and an x to the 1/2 that you could take out between the two terms. So I factored that out in this step, leaving me 1 plus 8 y to the 1 over 8 left over for the remaining factor. Hopefully this helps you out with those two problems on Achieve. Let me know if you have any other questions.